before if y'all who didn't know, my readers get 5s automatically today. I know it may be a little, too much to read to your class, but thank you so much. All right, so the important information that we're going to look at is alleles and heterozygous and homozygous. So before we go through this, in your Google Classroom, you have vocabulary terms posted just in case you forget what they mean. Then turn your device to portrait mode. I'm not sure. I don't have a Chromebook, or you can just follow along with me on the screen. All right, so all right, so let's look at it. Says they have, based upon which conclude this color is dependent on a single gene with 2 alleles in this population. Basically, an allele is their gene. Instead of us saying these are the time they're going to have alleles. And we have red people, we have blue people. So it asks us to design a Punnett square based upon what we see. Heterozygous. Now, if you were thinking about your English classes and we talked about prefixes, what do you think hetero means? You can respond in the chat or come off mute. What do you think hetero means?
Straight, I think. Okay. I don't know.
So thinking about, I knew someone would say this. So thinking about the sexual orientation, if you're straight, is the couple the same sex or different sex?
Different.
Great. So hetero just means different. So they're saying the alleles for Bob is different. He has a capital R and a lowercase r. And those are called his dominant trait, which is an R, capital letter. That's always the case, which is dominant is going to be capital letter. And recessive, that's going to be lowercase, but it's still present. That's where the lowercase r is. So he has 2 types of letters. For Mary, she has both the recessive trait. So if you see that Mary has 2 lowercase r's and it says homozygous, what does homo mean to you? Not in the sense of someone's sexual orientation, but just in general. What do you think?
Same?
Great, thank you. So she has the same allele. She has 2 lowercase r's. If you can't open the slide or this part of the slide, you can just watch along with me. So it says first drag the gene symbols into the edge of the Punnett square. So these are our gene symbols, and we see that Bob has the dominant trait of being red. So we're going to drag that at the top, and he has the recessive trait of being blue. Notice, even though the blue trait is there, it's not dominant, so he's going to be red. So we're dragging Mary's 2 traits on the other end. She's blue because she has 2 of the blue traits, recessive traits, and there's no dominant traits for Mary. So think about when you were in 5th grade, maybe 6th grade, and you multiply using that chart or that ray, whatever it's called. What do you think goes in this first square for this offspring? You can type in the chat or come off of mute.
What did you say?
What would go in this first square for this predicting that's first child? What goes in the first square?
Red.
What letters?
I don't know.
Okay, that's good if you don't know. So I do agree with Jordan. He said an R, okay, but we need something else. So we have 1 from Bob and 1 from Mary. So what do we get from Mary for this first square?
R, like lowercase r.
Perfect, there you go. All we're doing is taking 1 from Bob, 1 from Mary. All right, let's go to the next square. What do we get from Bob? Uppercase or lowercase? Type it in the chat.
Uppercase.
Uppercase? No, let's look at where in this space, Bob isn't uppercase. He has his recessive trait.
Oh, lowercase.
All right, and then what we get from Mary for this box?
Lowercase again.
All right, great. What do we have for the next box coming from Bob?
Uppercase R.
Good. And for Mary?
Lowercase.
There you go. Great. So we should see a pattern. And let's let everyone else answer. Amani, in the chat, what goes in our last box for this Punnett square? Okay.
A lowercase.
In the chat. What two letters go into, good, Jordan? And Trayvon, let me know in the chat. What two letters go into that last box? Good, Makai. Good, Trayvon. I need to see the letters. Good, Armani. Right. So all we're doing is looking at what we got from Bob, what we have from Mary, and we have two lowercase r's. Here's the fun part. Now we're going to see, what are the colors? So as we said, if someone has a dominant trait, that's going to be shown regardless of whatever trait they have next to them. Let's look at Bob, for example. The dominant trait for Bob is the uppercase R, then he's going to be red. So let's look at this first box. In the chat only, don't come off of mute. In the chat only, what is this first box going to be, red or blue? Good. Trayvon, Armani, wonderful. I need some more responses. What is this first box going to be? What color? Good, Shanice. Great. We should have said red. Look at the next box. They have two recessive traits, and what color is that? Good, Shanice. Anybody else? We have two recessive traits. We know that color is good, Deasia Jenkins. Great, y'all awake. Wonderful. Next trait. Once again, oh yeah, two recessive traits. What's the color of that potential offspring? Good. All right. Thanks, Jordan. And then lastly, we have a dominant trait and a recessive trait. What's the possible color of that offspring? Good. All right, last question. So we talked about, what's the chance if you have the same eye color as your parent? Some of us said 80, 60, 40, 50. So what's the probability of us having a blue child?
50%.
Good. How'd you get to 50%?
Because half of 100 is 50, and there's two sides of the chart. So there's two blue and two red, which means half of 100 would, and you just take 100%, you divide it by 2, so it would be 50%.
Okay, thank you. Right, Trayvon, two sides with different colors, so it's 50%. Great. All right, thank you for those that participated. Got our points for that. Let's continue on with the lesson. Nope. All right, so now you get your own chance to draw a Punnett square. Be mindful of the alleles that they have given you at the top, and it's asking you a question. So you're going to draw first, and then you're going to answer the question about the probability of having that type of offspring. Make sure you look at what they give you. Ooh, and then you're going to answer that last question once you're done drawing. You have 4 minutes. I actually see other pens working. It says await and draw. So I should see Arve, Ariana, Shanice, Amani, Deasia. Okay, thank you. Kamante, Jasmine, Eric, Deasia, Kamari, Michaela, Cassidy. Most of us are drawing circles. I don't know why. It should be a box. It should be a box. Punnett squares is a box, not a circle. Be mindful of your time. Great. Thank you to those of us who have those 4 boxes. Wonderful. Let's continue drawing, and then you're writing the alleles on the side and the top. Good. Thanks for all those corrections. Submitting on 2 people. I still see a circle. I'm not sure why. These are squares, not circles. Once it says time is up, they won't let you draw anymore, so please be mindful of your time. Refresh your... So this is showing me that you need help, or was the time too short? It didn't have to be a perfect Punnett square. With all you needed is the 4. Let's look at this person's. They have the 4 squares. My only thing would be you should have... Okay, there it is. So good. You should...
I'll be right back.
Text me next time. Right. So we should have spaced out the alleles for the square that we drew. What can I draw? Okay. What's going on? All right. So with our squares, make sure you show that it's an uppercase Y, and then you have one of those lowercase Y's. And then we should have the 2 Y's on the end. Like that's what when it was asking to space it out, that's what I meant. And then you can easily tell, okay, when I join these 2 together, like for Bob and Mary, they give me 1 gene from those 2, Bob and Mary again, and again until you filled up the Punnett squares. That's what I was expecting to see. And then you should have answered the probability question. If you have any questions, please let me know now. Or if it's like, Ms. Grants, I just needed more time to draw. Or I know someone told me that it kicked them out, or they had to redo or log back in. Okay, good. Okay, I'm about to say, okay. If the time was too short, no problem, no worry. We'll have more time to work on drawing a Punnett square. Okay. On Friday. And we'll do some on Wednesday. Yep. Wednesday. All right. It sounds like y'all knew how to answer these questions earlier. Okay. All right. So let's continue on. 50. Okay. All right. So we talked about a lot of different vocabulary terms today. And in this small reading, what I want to pay close attention to is what is different about this Punnett square that we have not seen in our recent classwork. You can respond in the chat or come off of mute. What is the difference in this Punnett square that we have not seen in our classwork for today?
We didn't see the images right there. Whatever that is right there. Like, why are they all different colors except the one down there?
Oh, that's what I'm looking for. Good. There you go. There you go. Amani. Great. So yes, that's what I wanted you all to see. Why is it different? So if you notice, we're looking at 2 heterozygous pairs. What we done in class is we had a heterozygous one, then we had a homozygous one. Like Mary was the 2